Hi, my name is Max Sullivan. Today we will be discussing Raspberry Pi Lesson 2. This code is provided by Baking Pi from the University of Cambridge and can be found online at the Cambridge Laboratory at this URL. If we come back, we're going to go ahead and talk through the code for a second. So if we go into here, we'll see that our first code is to load register R0 with the following hexadecimal number. The first 13 registers, as we note, are for general purpose, which means we can use them for a multitude of things. Now our first step is to move the value of 1 to register R1 and then shift that value 18 places. So you'll see in base 2, that's described as this binary number, 1 followed by 18 zeros. Sorry, I had to check and see if it was 17 or 18. Next, we'll come down and we'll tell the GPIO to store that one, or store register R1, which is now 1, 4 addresses away from register R0, which registers the 16th pin for output. We then go ahead and set or move a 1 into R1 this time and go ahead and shift it over 16 places, which would be much like this, just minus 2 zeros. We'll then go into our loop, which tells us to store that new R1 into location 28, which turns the pin on. It then is told to either, or it's then told to stay on for this period of time. Actually, we wanted to say 0F. I did a prior video for this lesson that didn't work out, and we'll explain why I changed that number in a second. If we come down here, but it'll stay on for this period of time, we'll come down here and we'll show that we then are going to tell the pin to turn off for this amount of time. And we'll just keep looping it, so you'll get on, off, on, off, and we'll see that the light is blinking when we go ahead and go through that process. Now the next thing we need to do is actually store that the kernel file that executes that bit of code onto our Raspberry Pi. So if we see our path, I've already added user and bin into our path variables so that this can be accomplished. So we'll go ahead and switch over to our C-ugarto user file where we've saved our source file. Go ahead and run a dir to see what's in there already. Now I already have run this once before, but for video purposes, we're going to run it again. So we'll go ahead and clear out our bin folders, or our build folders, as well as our kernel image that's going to be created when we run PyMake. So you can see we've now deleted our build directory, our kernel image, kernel list, and kernel map folder. Again, run a dir. They're no longer in the C-ugarto user file. So now we'll go ahead and we'll run PyMake again, which is going to compile. And we can see it compiled successfully. And once again, our build kernel.image map and list files were added back into our drive, or our folder. So the only thing we're going to need in order for this to run properly is our kernel.image file, which we can go and pull off of our user file. So we will go ahead and copy that and paste it into our SD card, which I have to add back into my machine. It was in my Pi for the time being. we had already added it in, but just for purposes of being thorough, we will use the new one that we just created. The rest of these files were given to us by our professor, Joel Rosine, in order for the rest of the Pi just to run in general. You can see that another kernel file is given to us, but it doesn't actually run the code that we just created, or not that we created, but that we just talked about. So we just gave it a nonsense name so that way it wouldn't be used by the Raspberry Pi while booting. So now that that's done, we will go ahead and eject our SD card. And put it into our Raspberry Pi, and then we can show that it's blinking, and lesson 2 will be complete. So it's kind of hard to see that it's blinking due to the case, but you can see a blinking light right there. But it's just, it gets a little muddied by the red light next to it. Just for thorough purposes, I said we'd talk about the fact that we could actually change how long they blinked for, and that's why I changed this to an F prior. If this is an F, this number is much longer in hexadecimal, so it would stay on for a lot longer. If we were to change this, for example, to a 1, it would stay on for a stay off for a shorter amount of time, and the blinking would be slower but more light, more time where the light was on. Anyways, that is Raspberry Pi Lesson 2. Thank you.